You can want it to happen, you can say it happened, but it's not going to happen unless there's a revolution in this area that will seem, in retrospect, like a miracle. Hydrogen storage, we just talked about it. There may be no wonderful answer. It may be the best answer is a pressurized hydrogen tank or liquid hydrogen. The good news is it ain't that bad. The bad news is it's never going to be like the gasoline in your car. So either we find the magic material X that we can put in the gas tank that makes hydrogen seem like gasoline, and we only have the periodic table to deal with, and we better be the first few elements, otherwise it's going to be too heavy. Or there is no answer, in which case you've got to change the car, you can't change the gas tank. But if there's an answer, it will be some manipulation of matter on the nanometer scale that will give us to it, something I like to call nanotechnology. Storage, batteries, supercapacitors, flywheels, to get them from where they are right now. This lead-acid battery was developed during the Civil War. We have still never beat the lead-acid battery. If there is an answer permitted by the laws of physics and nature, and physics and chemistry in this universe, the one we live in, it's only going to be found out of the garden of physical sciences and engineering. Power cables. We used to think the only way to get electrical power from here to there was copper or aluminum. And then we discovered high-temperature superconductors. And we're thinking that maybe we can have a high-temperature superconductor, liquid hydrogen around it, and we can pump both electricity and liquid hydrogen from here to there. And we really need to push that. Maybe we can really make that work. There turns out to be an interesting new answer, which has to do with my favorite thing, Bucky tubes. And doing this is what I call a quantum wire, where the electrons go from here to there because they go down Bucky tubes, these beautiful little nanometer diameter single crystals of carbon, like a quantized wave packet. They transmit electrons just like a fiber optic transmits a photon, a single transverse wave. And when it gets to the end of the nanotube, rather than going all the way from here to, I used to say Dallas, Texas, but we're in a different part of the country, from your power source, hundreds of thousands of miles to thousands of miles to where you're going to use it, rather than having to have that tube go all the way from here to there. You only have the tube go a short distance, and then it hops to an adjacent tube that is identical to the one you started with. And it does that by a process of resonant quantum tunneling. So it's though you're on a subway, and there's another subway train on the adjacent track, and you said, I go to sleep, and you wake up on the next train. You're still going with the same momentum. This is the quantum way. It doesn't actually move from here to there because particles don't actually do that in our universe. They have a much more romantic thing that they do. Dreaming of the new place, and they wake up in the new place. Resonant quantum tunneling. This thing, if it worked the way I've imagined, would have the electrical conductivity similar to copper, but only 1/6 the weight. That's a huge deal in transmission lines because it's a question of draping from one power line to another. The reason we don't use copper for high voltage transmission lines is they're too heavy. So we use aluminum, so half the electrical conductivity, but at least we get the strength. And suppose it was 1/6 the weight, and even stronger. And now instead of a cable being like this, we can have a cable being like this. Along the existing corridors, we can bring 10 times more electrical power. And if it's AC and the radiation bothers you, we'll put an insulator around it, we'll put a coaxial cable, there won't be any radiation around it. Quantum wires from nanotechnology, the garden of physical sciences and engineering. There are others. You can go down the list. I mean, looking for miracles. I'm convinced the miracles exist, and we can find them if we turn the switch on. There's another little issue here, and that has to do with the workforce. Who is going to make these great discoveries? Luckily, we've got the biggest scientific enterprise in the world, the finest scientists and engineers we've ever had. However, they're aging workforce. Most of us got into it in Sputnik, and we're running sort of on the fumes of Sputnik. Here you can see physics production, PhD production in this country in the last century. You see it dipped in here. That was the Second World War when people didn't get killed. They actually went out and they fought the war. Some of them here in Columbia involved in the development of radar and the Manhattan Project. Well, by and large, all these guys got their PhDs. Back here, that's this bump. It would have gone up like that, but right in here happened the Sputnik event. Sputnik happened. There was a lot of fear that we were technologically incapable of winning the Cold War with the Russians. It wasn't so much that they put a rocket up. They said our rockets blew up the pad, and every rocket they tried went up further and further. And we had Russians in space, and this was in the duck and cover eras, and we were scared. Well, that Sputnik event even though it instantly said to most people, science and technology, we better get going on it, it didn't say, let's go to the moon. It took 3.5 years before Kennedy found a way of taking actually the energy that was generated by the concern and the fear of Sputnik and found a way of a program that not only allowed people to get involved in something that ended up being sort of the answer to it, but it gave them that sense of passion and inspiration and grandeur for their lives. And most of us got into science because of that. I believe 9/11 is a similar event to Sputnik. And just like in the case of Sputnik, it took 3-4 years until the administration found the grace to propose a program that harnessed that energy and directed it into a positive way that produced so much of what we have around us. I mean, pretty much every industry that you know of that makes money, that makes things good, started with the technological innovations in the 60s and the people who went into it. I believe there is a time we're in right now when we're trying to formulate how do we take this anxiety, this sense of hopelessness about terrorism forever, and the whole world. I mean, what happened when the Twin Towers came down to most of us is we realized that it's never again going to be true that we can, even in a cocktail argument, pretend that the problems of the world aren't going to be our problems, that they were, so the problems of the world are a big issue. That there is an opportunity here to harness that energy that's been built up, the sense of anxiety, into a very positive channel, which will not only solve the energy problem, but give us the cornucopia of new technology. It's fascinating. You might say from this chart, well, I see the peak. We came from Sputnik, 69, 70. We dropped off from PhD. They came back on up. And after all, how many PhDs in physics do you really need? Well, it came back up mostly not because of U.S. citizens, but thank God, really brilliant people coming in from overseas to get their PhDs, dropping off actually precipitously right now. But how about this level? How many PhDs in physics do you need? Well, what's relevant here is it's not just physics, it's chemistry, chemical engineering, mechanical engineering. They all pretty much look like this, the same Sputnik effect. Physical science and engineering, we're having a terrible time with the work product. And how much do you need? Well, what's relevant is to realize that the developments that these people make, the guys and girls who make stuff and make stuff work, the physical science and engineering, is the basis of pretty much every big and small industry out there. And so what's relevant is not the total number, but how it compares to the overall level of economic activity, because we're in a high-tech age. So you ratio that to GDP, and you see this curve, and now you see very vividly the Sputnik generation. Just imagine what the world would be like right now if we didn't have the inspiration, that generation that came in, 10, 20 years of people that went into the field. And so the notion of what I'm picking is that 9/11 was another such event, and if we can find the grace to find a new program to channel people into these physical science and engineering, that's very hard disciplines, it could end up having a very positive effect. We've known about this workforce problem, physical science and engineering, for at least a decade. We've done all sorts of things. The NSF is knocking themselves out to solve it, and has been for a decade. This is how effective we've been. This is the U.S. production of PhDs in all the physical sciences and engineering over time for the past 15 years. And you see it's basically been a flat line. It's actually dropping off. 2003 is not in here. It's down. So you think all the stuff that's been done for the past 10, 15 years there, every time we've had conversations about doing something about it, we're going to do something, that's been our effect. And while we're having this effect, or little effect on the physical science and engineering, in the real world that we live in, this is what's really happening. And it's primarily, it's China. I've had many of these students in my group, and some of you in the audience have had, these are extraordinarily bright, hardworking people. I just don't buy the notion that only Americans to do the innovative science like Thomas Edison. I mean, these people are very creative. And they are heading into these fields, the science, and particularly physical science and engineering, in high numbers, not only in China, but around in Asia. We're heading into a world where basically American boys and girls have opted out of this field. It just happens to be the field where the innovation, the revolution of the world's biggest enterprise is going to happen, the physical science and engineering. Do you really want to be out of that business? And will this renaissance, well, the growth of the physical science and engineering in China happen fast enough that they'll be able to find the answer? Will they find the new oil soon enough? So in summary, I believe, for the reasons that I said, that if you had to pick one issue that's more important than any other single issue, it is energy. You could have picked any other one, but energy is something we can do something about, and if we do it, we can affect positively most of the other problems addressing it. We ought to get on it. The task could be 10 to the 10th people. Energy for 10 to the 10th. Let's get it clean, cheap, and continually available. And the magnitude we are after is a huge amount, effectively equivalent to 150 million barrels of oil a day. We only use worldwide 80 million barrels of oil a day right now, of oil. I want almost twice of that from the new energy source. For worldwide peace and prosperity, it has to be cheap. We can't do it with the current technology. We need to get American boys and girls and people around the rest of the world to embrace this issue. If you agree with me that by the middle of the century we have to have done this, if you know and you believe that we have to revolutionize the biggest enterprise in the world in energy, what is it that we're waiting for? Why would we wait until it's just trivially obvious to everybody on the planet we have to do it before we actually start to do it? It would be much more to ours and the rest of the world's best interest to get on the problem right now. I mean, as I said before, even if it turns out we fail and you can never find another oil, this will be the basis of the new industries anyway. This will be the cornucopia of new technologies. If we're waiting for an energy crisis to trigger us into this, I don't know what it would look like that wouldn't be as deniable as our previous energy crisis. I mean, how about the power blackout? What's wrong with that? Well, you can say, well, there's a little hiccup that happened. You know, how about the last time oil prices went? Well, maybe we'll discover new oil. I mean, there will be a time that will be so transparent you can't get away from it, but I wouldn't wait for it. If we're waiting for a global warming disaster, I can't imagine one short of the Gulf Stream turning off that would be enough to trigger this. I think this conversation has been so polarized now. Talking about global warming is very much like talking about abortion. I mean, there are people that believe in pro-choice, and there's people that believe in pro-life. And you have this conversation, we all talk to each other, and we're still pretty well sitting in the same place. That's probably overstating the global warming thing. I think it is moving, but still, with the current administration where we are, we're stuck. Are we waiting for a new administration? I don't see any evidence that a new administration would be any more aware or able to handle this problem than the current one. If we're waiting for an Asian technology boom, I guarantee we're going to have it. But realize it takes 20 years to make a scientist or engineer. We don't have time to wait for that to be our stimulus. So I believe what we need to do is talk about it, honestly, openly, to criticize back and forth, find out what the real answer is here. We need a consensus amongst the people who really have this responsibility now, the science and technology establishment of this country. So DOE, NSF, NASA, everybody in the energy business, this broad, huge scientific and technological those guys and gals that make stuff work, we have to agree that this problem is really, as I say, and responsive. And we have to get the DOD to agree, and I think they do. They're very concerned about energy, and they're very concerned about science and technology workforce, particularly U.S. citizens. They can't hire anybody else. The intelligence community, I think, by and large agrees. State Department about the pivotal role that energy plays in the stability of the world. Once we get that consensus, then I believe it is there is now an opportunity for political leadership for someone, maybe George Bush, to stand up and say something like Kennedy said, but drafted in a way that really inspires people. I mean, it's not just that we went to the moon, it's what happened to people's souls in the 60s. That's what we have to get. I believe it's there, and I think we ought to push to do it. Thank you for your attention.
Thank you, Rick, for a very exciting and interesting and stimulating talk. Rick has agreed to answer a small number of crucially important questions. So if you'll wait, I'll try to recognize you, and then if you try to use that microphone in the middle of the room or speak very, very loudly, it would help. So are there a few crucially important questions for Rick? There is one right back there.
Thanks, Professor Smalley. I'm Jack Mason from Small Times Magazine. We cover the commercialization of nanotechnology, and I and you obviously have an important company